Good evening, everybody. Welcome to tonight's episode of the Triangle SQL Server Users Group. I'm calling them episodes now because, well, I could call it a misspeak, but, I'm just going to roll with it. So, with tonight's presentation, Joseph Fleming was kind enough to jump in at the last moment and talk to us about about Query Store. I've flubbed twice in 1 minute. This is actually normal for me. So, we're going to talk Query Store. And with that, I'd like to hand it over to Joseph.
Thanks, Kevin. I appreciate it. And yeah, definitely, if you're here for Column Store, this will not be a very enjoyable presentation. But Query Store, for sure, I hope that you get some enjoyment out of it. So to start off with, I'll tell you a little bit about myself for those of you who don't know me. My name is Joseph Fleming. I began working with databases in 1995 in the medical records keeping field, so healthcare information systems. I started working with SQL Server in 1998 and officially earned my DBA title in 2000 when I went to work for a bank that has since been acquired probably 2 or 3 times by now. I feel like oftentimes some areas of Egypt have dirt that's older than me, various aches and pains. I'm really not that old, but it just feels like it, especially now. I look terrible because I haven't had a haircut in a month or more, actually 2 months, I should say. So much more of my gray hair is showing than usual. And if you are not a fan of dad jokes, bad jokes, or puns, this is your chance. Go ahead and just close the window, pretend you were never here. So let's talk a little bit about the Query Store. It was introduced in SQL Server 2016. It collects and stores query and plan information in your database. Now, though the feature was introduced in the SQL Server 2016 boxed product and available with Standard Edition and Enterprise Edition, it had actually already been in use in the Azure version of SQL Server for a year at that point. So it had a lot of testing even at release time, and even more since then. So the Query Store can be turned on independently of your DB compatibility mode. So even though you may have your database compatibility mode set all the way back to 2008 R2, you can still turn on the Query Store and still use all of its functionality. It comes with several interactive built-in reports, which we'll take a brief look at. And you can use it to patch some query performance problems. So let's take a look at what it looks like. So we're actually, I've got the Query Store turned on, but I actually just restored this database this evening. And so I actually need to feed some information into it before we get going. So let's start out by executing my, my very, very good titled stored procedure. And you'll see why later on. This is, it's titled as it is. So we're going to just execute it a couple of times to see, get the information that we need, and then we'll take a look at our Query Store. As you can tell, maybe the different types of parameters that I use do impact the runtime of my query. This is taking longer than I remember. There we go, 20 seconds. Okay. So when we enable the Query Store, we will get this Query Store folder showing up in our under our database tree. If it's not enabled, that Query Store folder just simply won't appear. So when we expand that tree, we get a few options from our reports. We can look at a report on regressed queries, on overall resource consumption, top resource consuming queries, or queries that have been tracked. So we'll show you a little bit on that later. So we're going to look at the top resource consuming queries, and I'm just going to double click that, which will kick off a report. And here it is. As you can see, it's got a report of the couple of queries that I've executed since I turned on the Query Store. one obviously using a lot more resources than the others, and the different plan IDs that may have been used by that query. So now we can see here, it's going to give us, if we hover over, we can see that we actually have a query ID of 38 for this particular query that used most of our resources. So if we then come in and we look at the tracked queries report, we can enter that query ID and see what it might tell us, right? And we can see, again, it's got one plan ID in the last however many days this is showing us by default, and we can reconfigure it so that it's really only going to show us, let's say, the last hour. Oh, that's nice. That's not what it typically looks like for me. But yeah, usually it doesn't pile up the time frames quite so much. So we will see later what the potential differences are in our plan ID, but this is just kind of a little basic detail of what the query store looks like and some of the things you can do in the standard set of reports that it offers. All right, so we're going to close these windows and we're going to get back to our presentation. Oh, I didn't show one thing that I do want to show you guys, and that is that you can use the query store to patch some specific query problems. So we're gonna free the procedure cache. We're gonna execute this procedure again. You're gonna notice this time that it should come back much faster in about 3 seconds. And now if we look at our tracked queries report, we should see a couple of plans. Oh, I've got to put in the actual query number. Right, you can see our original plan 6 that we looked at earlier, and you can see our new plan number 8, which executed much more quickly. Right, so I can actually go through here and I can say, listen, this query plan number 8 works way better for my store procedure than query plan number 6. So I want you to always use query plan number 8, and I can click this button that says force plan. And now going forward, we can make sure that this is the plan that SQL Server will choose. Spoiler alert, this does not always work. So let's go back to our presentation and maybe find out a little bit more about why that might be. So as you just see, we can use this force plan option. It's a fantastic technique for patching up queries that suffer from parameter sniffing issues. We can use this force execution plan idea to basically tell the optimizer, hey, that was a bad plan over there. Let's not use that one again. Let's only use our good plans. So let's kind of show you what that looks like in action. Oops, that's a little jumped ahead. All right. So as you can see, I forced it to use this plan, and let's find out how well that worked, right? So in order to see whether or not that worked, we're going to free the proc cache, right? We're going to execute this procedure again, sorry. And then we're going to execute it again with our other set of parameters. Oh, I said we were supposed to set our statistics for time and IO on so that you can see. So we'll just rerun this again. So if we look at our messages, we can see we had a scanned count of 5, a logical reads of 17,000 for the transaction history table, total execution time of 64 milliseconds. CPU time is 218 milliseconds. So pretty fast, right? Now we're going to look at this one that we run. And we would expect, since we forced that good plan, for this to run in about 3 seconds. So let's see what happens. Well, we've run past our 3-second threshold. Something doesn't appear to be working the same way that we thought it would before. Now, the initial run that we did took about 20 seconds. That was because we were actually having to read the data off of disk. Now that it's all kind of stored in memory, it actually dropped down to about 11 seconds for our second run. But you can see here that we have about the same number of logical reads, 17,701, but we had a fair amount of scans going on, had a lot of data affected, right? And our CPU time and our elapsed time were much higher for this version of the query. So what the heck happened here, right? Like, why we forced the good plan? Why didn't it go back to taking 3 seconds? And will it go back to taking 3 seconds if we free the proc cache and then just run my procedure again? Let's find out. Here we are. Same amount of time. So let's go back into the query store and take a look at what may be happening. Right, we can do a refresh of our executions. And all right, so this guy, plan number 8, he's executed 5 times. This guy up here, he's executed 2 times. Let's see what happens if we force this one instead. Can we get our execution time down the way we want it to? So we'll free the proc cache again. And again, we're going to start with our slower proc. Right? And then we'll go back to using our worst set of parameters. Let's see what's happening. Again, we seem to be back up to taking a lot longer than we were before. As you can see, now I'm doing a lot more logical reads, right, out of memory than I was before when I forced that second plan. So what the heck's going on, right? Like, why am I not having any luck here getting what I want? So normally, this is where we go to ask the audience. And I would ask if anyone has any ideas for why the forcing of the plans didn't work the way we thought it would. So, oopsie. Again, I'm skipping ahead because I'm trying to use the wrong buttons to move. All right, so we're going to take a look at the query store to see if we can figure out anything that might give us a clue about what's going on. So the first thing we want to look at is the query store query table. That's going to hold information about all the different queries that we've run as part of our stored procedure. Now, we can see we have 2 query IDs, 2 query text IDs, their SQL handles, and their query hashes. So we've got basically 2 queries. What's going on with them? When did we initially compile them? When did we last execute them? Basically, what I'm really looking for here, what I really want to get, is just my query IDs so that I can take and paste those in and get some more information, right? So, or I can use this object name of the object ID and do a join back and see if I can just look for my DOM stored procedure, right? So here are the 2 queries and what they look like with the query IDs. So my query ID 38, which is the one that you see in the report that took a lot of time, does an insert into this temporary table. And then the other one does a select top 10 from that same temporary table. So the next thing we're going to do is take a look at our query plans to see what's in there. Right, so we get 2 instances of the query plan. We get a query plan number 6. We get a plan ID of 8. And we saw those again. If we looked in our tracked queries, right, those correspond directly to our plans that we can see here. Plan ID number 8 and plan ID number 6. Right, and we can see they both correspond to the same query and they both have the same text. So the next thing we want to do is try to figure out which is the plan that's running along. I have the screen resolution expanded so much that it's hard for me to select the text. Here we go. All right, so somehow we ended up with live query statistics. I must have clicked that somehow. So looking at our average duration, we can see we have a plan ID number 6. Average duration is, and these are in microseconds, 8 million microseconds. Plan number 8's duration is about 5 million microseconds. And so this averages out to around 5. This is about 8 seconds. And those numbers have changed simply because of which plan is getting used. And we've executed them both a few times, right? But if we look, and here you can see I had referenced plan number 5. That's how it came up when I first did the demo. But really, it's plan ID number 6. Let's look at plan number 6. And plan ID number 5 is not what I want. We're going to change that to number 6. Sorry. So we can see here that we actually do get the full query plan. And we can get the query plan hash. And this is important if we're trying to find some information. So what we want to do, again, we're going to join on this query plan hash, right? We want to look and see if we can find that in the DM exec query stats table. We can look at that. So now what do we do, right? What are we going to do with this bit of information that we have? We've got the plan, right? We've got the query plan hash. We've found it in our cache. What do we do with it, right? Well, so let's take a step back and say, why didn't my forcing of the plan work? Why did I not see an improvement in my query performance? And normally underneath the query store, I actually have to take a look here. This plan is forced. We should have a view here that is basically queries with forced plans that would give us a little bit of information. But it's for some reason choosing not to appear for me right now. That may be because my query store flush interval is too long or some other reason, but it's not showing up. So I apologize for that. But normally you would be able to look at all of your queries with forced plans in one of these views, and you could see the reason for your plans being forced or the plans failing to be forced. So what we're going to do first is take a look at the stored procedure that I wrote. It is really a pretty dumb stored procedure. The only thing we're doing is creating a temporary table, inserting some data into that temporary table, and then selecting the top 10 records from that temporary table. But this is an easy way to demonstrate why forcing a plan with the query store won't always work. And that's because inside this stored procedure, I'm creating and then we will be dropping a temporary object, right? And because that temporary object is going to get a different name in tempdb each time, this plan can't be forced. So later, oops, wow, that's terrible. Sorry about that. So because it can't be forced, we don't really see much impact from trying to force a specific plan using the query store. So here we go. Is this a bug? No. The query store references very specific objects. If the object no longer exists, then the plan isn't valid anymore and can't be forced. So in here, which is the object's name that's changing? And normally I would have a couple of, I would be able to ask you guys to look at the screen. We'll just take a quick look here, and obviously you can see, I think I actually have to scroll backwards. If we look, it is the name, the object that's changing is that temporary table, right? The name of that is changing, or is it? The thing that's actually changing is the name of the clustered primary key, right? So what I'm getting is a randomly assigned primary key name, and that name is going to change. And depending on which plan we look at, and let's take a quick look back here at these two different plans. Here we can see we do a clustered index seek on the product table. We do an index seek on the transaction history with a key lookup here, and we do a clustered index insert, right? So that's my longer running of the two. The second one, we actually do clustered index scan, clustered index seek, clustered index scan, some parallelism, which is great. But again, we get a clustered index insert. And so this clustered index insert, which uses that temporary primary key name, is no longer going to be valid when we run the store procedure a second time and we create a brand new temporary table and we get a brand new primary key name. So what can we do about the fact that that object's name is changing? Could we fix this if we used the auto tuning feature of SQL Server 2017, right? We've got SQL Server 2017. We could turn auto tuning on, but we can't force it. And that is, the auto tuning also would not help. And that's because where auto tuning uses the query store to do basically the same thing that we do, only it's automated. It monitors the query store. It watches for a plan regression to happen, and it says, when I see that happen, let's force the old plan, the better plan that it was using before. Unfortunately, again, we will not be able to force that good plan. So if we can't force the good plan, we fall back on a wise piece of information, wise procedure that my dad always used to say, and that is, you don't force it, you just use a bigger hammer. And so we can't force the good plan, but we could boot the bad plan out of the cache, right? Oops. So let's take a look at potentially doing that. So first, we're going to have to create a, let's make sure actually before I do that, that I get the, pardon me, that I get the actual bad plan hash here.
While you're grabbing that hash,
Sure.
question came in from chat. Could you show again how and where it shows that you can't force this plan?
Yeah, I wish I could. There's supposed to be a new report here under the query store, and it would be called queries with forced plans. And it's for some reason not appearing here. Let me look and see if it actually appeared in my previous one. And it's not appearing there either for some reason. But there's typically a report. Now, if you give me a little bit of extra time at the end, there are some query store tables that we may be able to look through, and basically the report is a view into one of the tables. So we may be able to find that towards the end of the presentation. I don't want you to have to watch my Googling skills right now so that I can find the exact table name. But basically, there's a table that will say, you know, these are the queries with forced plans, and this is the forced plan failure reason, right? If that's null, it means it's actively forcing plans and everything is fine. But if it's not null, you'll see one of a couple of reasons. You can see No plan, which is what we have in this case, basically says I can't use the existing plan because it doesn't fit with the objects that I have. And that's what you would see. So we'll try to circle back to that as we get to the end, if that's okay. All right, so let's take this and kind of reset ourselves so that we make sure that we've got everything that we need for the next phase of the demo. I believe we still have a forced plan set in there, but it still shouldn't work. Good, and then so the last thing we want to do is make sure we get our query plan hash, which is very important for demo number 3. But if you notice, it's the same hash, so that's good. So what we're going to do here is we're going to create a table, right, that has the object name that we're trying to resolve and the hash of the bad plan. So we're going to execute that. We're going to create our table. We're going to insert the object name and the name of the plan that we want to watch out for, right? And then we can periodically check for this known bad plan, right? And let me we'll reserve this. I'm actually going to shrink the view down just a little bit because this is a little bit big. Make it a little bit easier to see overall what we're going to do. So what we want to do is check it out and set our look back period, right? To say how long do we want to look in the plan cache to see whether or not this has appeared, right? We can look in the past 15 minutes, we can look in the past hour, we can look at the past 5 seconds. We do use a minus here because we want it to look back 15 minutes and not forward 15 minutes. And so we're going to look through the cache and see if that plan exists. And if it does exist, we're going to take one of 3 potential actions, right? We're going to raise an error and potentially send a message, right? That say, hey, one of your queries has a bad plan. Now you can customize this error to a varying degree, and I'll make it send emails or give it a better, more informative message by building a string ahead of time so that you can tell it exactly which query or which stored procedure is having the bad plan if you've got more of these. But option 2 is we can look through the cache and build a set of statements to potentially resolve that issue, right? We can create a DBCC FREEPROCCACHE statement with just that plan from the cache, right? The SQL handle actually is what we'll be pulling out of the cache, and just dump that one single plan out of our cache. We could also potentially take a third set of actions. So first, in order for us to get the bad plan in here, I've actually got to go back and rerun because I did a FREEPROCCACHE, I think. Oh, no, wait, no, I didn't. But let's just take a look in our plan cache and see if that bad plan appears. Okay, so we need to quickly just kind of snip this out of here if we want to do that. We just want to take a look at it. So we can definitely see that that bad plan does appear in our cache now, right? We've identified it as the bad plan. We definitely don't want it to get used again. And so we can flush it out of the cache. And I'm going to reverse that last thing I did. So we get back in. And so it's actually going to do 3 things. It's going to raise an error for us. It's going to give us a statement, and then it's going to set up a recompile. So we're going to comment out the recompile portion, and we're just going to let it give us the statement to fix the problem ourselves, right? And let's just highlight that so you can see the whole of what we're executing here is the query to find our bad plan. So we immediately, get this error message. Hey, one of your queries has a bad plan. We also get this result that says, hey, would you like to free the proc cache? And it's given me a weird character in here. What has happened there? That's not what's supposed to happen.
Is it that the convert varchar is converting it to a varchar 1? Yep.
It shouldn't, but we'll expand that. Let's try this. No, we're getting the same problem, and I'm not sure what's caused that. Looking for the SQL handle. Let's just see if we can grab the SQL handle from here. Where is this grabbing? Query store runtime stats. Where is this getting it? From DM exec query stats. All right, sorry that I'm doing troubleshooting during this presentation. Looks like something has gone a little bit awry since the last time I have set it up. So I appreciate your patience. Even if you're actually not being patient, I don't hear any whining, so that's what I'm assuming is that everyone's being patient. All right, I've been able to grab the SQL handle. Again, I'm not sure why it's not coming through properly when we do the convert here, but we'll take a look at fixing that. So we're going to copy the command to DBCC free the proc cache. I'm going to grab this, delete whatever little special character that was. And we have now flushed it out of the cache, right? So now if we go back and we execute our query with the heavier set of parameters, we should see it executing again in about 3 seconds. Well, that's embarrassing. I'm not sure exactly what's going on because we forced the bad plan out of the cache. Well, let's take a look and see if we can see whether the bad plan is indeed there. So we are still having the bad plan. I'm wondering if it's actually somehow forcing that bad plan to be used through an update. So let's take a look at our tracked queries again, and let's do a refresh. We should be able to see again. It's breaking this down by hour periods. Let's see if we can get it to break it down a little bit more granularly than that, right? So we see this is our forced plan, and this is indeed the only plan that we're getting. So let's unforce that plan, which honestly, I'm not sure why that's not working. We'll free the proc cache and we'll do this again. It's going to be a little bit embarrassing for me. That should now complete in 3 seconds or so. It is. So somehow the forcing of the plans, and I'm wondering if a SQL Server update has fixed my issue, is allowing it to continue. So let's take a, this is an opportunity for us to kind of take a look at what's going on here. So we see this clustered index insert of this particular clustered index name, and I wonder if that's somehow getting reused when we're building this. So we'll have to take a look at that in a minute or two. But this is our bad query. We're using these index seeks, but again, this object here should be rendering this invalid. So let's find out. We've got to grab our dumb store procedure. So we're going to open up a new query. And we have it. And so I think what we're going to do is take a look at the query plan that's associated with this. So if we look, we are getting the same name, I believe, being used for our primary key. It's this 59D8EF4577888DD0. And if we look here, no, that's a different name. But somehow, that while that should be rendering my plan invalid because it's got the wrong name, it isn't. And so that's, like I said, a little bit of an embarrassment on my part, because I should not be having this problem. So what I have here is a stored procedure that needs to be reworked a little bit to actually demonstrate the problem that I've been trying to show you. And I don't know if we've got enough time to try to do that or not, but let's give it a shot here. Oh, I closed my query, right? So so let's see if we can't make it an even dumber proc than we already had. What could we do to make this less, basically force it to use this index? What have we gotten? We've inserted the name, transaction type, transaction date, quantity, and actual cost. If we use what can we use? Well, I need a moment or two more just to think about how we could structure this to prevent basically the reuse of, because what I suspect is that it doesn't care that this name is different because it's simply a clustered index insert, and it's disregarding this plan name here. So something about that has gone sort of wrong, and we'll try to figure out why. I wonder if my queries with force plans are not around. Okay. Just make sure. Perhaps I'm looking at the wrong thing. So let's take a look at our queries again. Query 8 and query 9, 39. We've done a free proc cache a few times. No, it's still, this is our longest plan, getting that information. So let's take a quick look at that plan again. Yep, that's kind of the guy that all right, guys. Well, I do have to apologize. This this should be working, and it isn't. So one of the worst things that can happen to you as a speaker is when your demo goes awry. I did do this same demo and presentation about a month ago in Cleveland, and it worked almost flawlessly. So I'm not exactly sure what has happened with the scripting or with the database to allow it to cause an issue here. But the general premise holds true, is that there are certain queries that you will not be able to force their plans simply because of the use of temporary objects whose names change, or an index that gets renamed or something like that. And if you would like to be able to still have some sort of control over whether or not the right plan is getting used or whether you're finding parameter sniffing, you can build yourself a set of alerts using this query, and I will share these queries and these demos with Kevin so that he can post them out for your user group. And actually what I'll do is, after this is over, I'm going to come up with a demo that actually works, and I will make sure that he gets that one as well. But you can use this query still to identify the known bad plans in your system so that you can flush them out of the cache when you see them. And that was the overall goal here, is to identify queries that have a known bad plan that this is not going to work well for you. Let's make sure that I find that one and I get it out of the system on a regular basis when it appears. Right, so we're going to go back here. What options, alternatives, basically didn't we use in order to try to correct this problem? We didn't use SP recompile or option recompile to do this. And part of the reason why we didn't do that is because you don't necessarily want to recompile so for option recompile, right, we could fix an issue like this by putting an option recompile in that query, forcing it to grab a new plan for the query each time. But what that does and what that can do is, on a highly active system, you can end up forcing a lot of recompilations and adding a lot of extra CPU. SP recompile is similar in that it's not going to fix anything until the next time the procedure executes, and it's also going to force a recompile of the entire stored procedure. Right? With this method, what we're going to be doing is removing the bad plan for that one single statement inside of the stored procedure, right? Because you never know how long a stored procedure could be. I've seen stored procedures at some customers that are 10,000 lines long, And if I force a recompile for that entire stored procedure, I could be asking the compiler to do a lot of stuff, and I could be inadvertently now getting a poorer plan for certain other parts of the stored procedure. So I don't want to do that. I want to do this really in a targeted manner. Another thing I didn't do is update the statistics. So updating stats on all of the tables will force the plans to recompile for those tables, but I don't necessarily want to do that because that may force a lot of other stored procedures or a lot of other statements to recompile that I don't necessarily want to have recompiled. Again, what we're looking to achieve is a very targeted thing. And DBCC FREEPROCCACHE to dump your entire procedure cache also won't work very well because, again, you're going to be dumping the entire procedure cache just to try to correct one problem. It's like, trying to kill an ant with a sledgehammer. You're probably going to do much more damage than you need to. Rebuilding indexes is similar to updating statistics in that the only reason that rebuilding indexes actually helps with queries is because it updates the statistics, and those updates of statistics will force the recompile. Finally, you could always set the building on fire because that's kind of what I feel like doing this evening after my wonderfully great demo.
As long as you collect the insurance money, that's the critical part.
It's important when you do that you make sure you have a good alibi. So we did talk about, I had actually skipped right into the third demo, which was automating some of it, and that was basically building a set of commands that would do your FREEPROCCACHE and other things like that. So I actually got a little bit ahead of myself with demo 3 here. Whoop. All right, so I want to quickly talk about some horror stories when using the query store, and where it can basically cause you more pain. Here we think, well, we'll just turn on the query store, we'll get all this great information, and sometimes things can go terribly wrong when you do that. So if your server has a very, very heavy ad hoc query workload, you can end up causing performance problems for yourself because it's trying to capture each and every one of those ad hoc queries as they're coming in and re-identifying them and reassociating them in the query store. So you can end up causing performance problems there. So what you may want to do in those situations, you have a couple of options. One is don't turn on the query store, obviously, but the second option is you can set the query store's capture mode. Let me give you a little show there to automatic, and that should ease the problem. So if we go into our query store configuration here, we can see our operation mode is read write, and our capture mode is auto. So that's by default how it sets up. But you can also, some people say, I want to capture all the queries, right? I don't want SQL Server to decide. So you may end up with the capture mode set to all. And if you do that and you have a lot of ad hoc queries that run very, very quickly, it can get overwhelmed trying to track them all, okay? So use automatic and you should be much safer. The next thing is you should make sure that if you are using SQL Server 2016, you patch yourself to Service Pack 2 Cumulative Update 5. If you're using SQL 2017, you should patch yourself to Cumulative Update 11 because there were some performance problems with the query store within versions prior to that. So definitely make sure if you're going to use the query store that you patch to those levels. If you have servers with a lot of databases, and by a lot of databases, I mean more than 100 databases, and probably even potentially more than that. I have a customer who's got about 500 databases or more on a single server, and they thought they were going to be very, very clever, and they enabled the query store on all the databases using SPMS for each DB. was great, right? I got all my databases. I got the query store turned on. I got it configured identically. It's all going to run really, really nice. What happened was there is a automated cleanup that happens in Query Store. Suddenly, for all 500 of those databases, that automated cleanup was triggering at the same exact time on the server every single day. It was shifting by a few seconds just due to clock drift, but so they would have a massive performance problem right at that time for a very short time every single day as the query store went in and tried to do its cleanup on 500 databases at once. So if you're going to enable the query store on a server with a lot of databases, do yourself a couple things. Stagger turning it on and also stagger your cleanup interval. And let's see the cleanup interval here really quickly. So we have what's called the stale query threshold. That's the number of days that it's going to keep queries in the query store that aren't being used regularly. And that's what triggers the cleanup. So you may want to set them to 30 days on some databases, to 31 days on others, to on up through 45, just depending on how many databases you have and how far you want to stagger those things out. The other thing that causes me some problems when the query store has been running for a while and has been gathering data for a while is the top resource consuming queries report. I actually have this report timeout on me on a fairly regular basis, which is really annoying because I really want to see what resources are consuming, what queries, I'm sorry, are consuming most of the resources from the query store in my environment. And if you're trying to do large custom queries against the query store, that can also cause you some heartburn. You can cause some strange error messages to appear within SQL Server there within your query where it just basically aborts you and throws you out. So a couple of tips for doing custom queries against the query store is use the no lock hint or use read uncommitted, because you're really not that concerned with data integrity at that point. What you're trying to do is get trends. So the fact that your data might change a little bit from your query is okay, right? I'm not looking to make sure that my bank account balances. What I'm looking for is which queries are the worst in my system. So those are some of the horror stories there. And so I actually built and included with the session materials a quick query that will help you look at some of your top worst performing queries. And I will show you that one really quick here. Where did that one go? I think I'm going to need to find it in Management Studio. Here it is. Good. So I've based this on a query that I've used at a couple of my other customers. We're obviously not going to see a whole lot here, but what we're going to look for are the top 50 from our environment. We're going to sort it by the plans. We're looking basically what I want to see, and generally what I'm looking at when I'm looking for a performance problem is the reads, right? That typically indicates the load on the system, but you can adjust this query to be to look at CPU, to look at duration, to look at writes. All of those things are captured by the query store. For servers that run a very, very high workload that might have a ton of very small queries, I want to limit the anything that has a lot of executions, right? Because even if I have something that typically does 10, 15, let's say 100 reads or something like that, but it executes 5 times a second, that's going to overwhelm my report and show up there where I probably don't want it, right? I can't make that any better. So I also use the max.1 hint because of what I've found is that I tend to get intra-query parallelism deadlocks looking at the query store a lot because it is constantly being written to while I'm trying to look at it. So I try to use the option max stop 1. And I have to make sure that's not highlighted before I click execute. But what you'll end up with is something that looks like this, right? I've got my plan ID, I've got the total number of executions, the total number of reads, the average duration, and what my object name is, and then in there, what the SQL text is, so that I can go in, I can look at that stored procedure and that SQL text and maybe say, hey, do I have some indexes that I could add here that might make things better? Or, is there something about this stored procedure in this particular statement that I could rewrite to make it better? So this also will be included with the downloadable material that Kevin should be able to get for you. I hope I'm not misspeaking there, Kevin, in that you will have downloadable material.
Yes, absolutely.
Great. All right. So the last thing I want to talk about is a few really great query store resources. Aaron Stellato, who is probably the top resource in terms of query store, has done the most research with it. Blogs at SQLskills.com. She works for Paul Randall and Kim Tripp, and has a lot of great information on the query store. I also, when putting this demo together, used Grant Fritchie and Kendra Little's websites to gather a little bit more information on some of the queries I might need to find in there and to look for things. So all of those resources are great if you're going to be looking to use the query store. If you have any questions, we can handle those now. We can also kind of, while I'm waiting to see if there are questions coming in, I'm also going to be looking up the query store table that I need to look at for the forced plan failures.
While you're doing that, I'm going to throw this on screen. This is Tracy Baggiano, our own Tracy Baggiano, and Grant Fritchie's book, Query Store for SQL Server 2019. Recently came out. Apparently I pulled up the UK version, or the Spanish version because it's Euro. But I could click on the USA site. Nonetheless, Tracy and Grant have a book that just recently came out right around past Summit timeframe. It's a great book too. So there's another excellent resource for you. And while he's looking, if there are any questions from chat, please drop them in here and I will pass them along.
Okay, so while we're waiting for some more questions to come in, I actually did find the table that we're looking for that will talk about the forced plan reasons. So that is select star from sys.query store plan.
So, important question for you. What did you give up for Lent? Mala had to ask that. Answer, demos.
Yeah, I'm definitely giving that up now. That'll be my post-Lent thing. I didn't expect to give up as much as I ended up giving up, obviously, along with most people, but I actually gave up sweets for Lent. And so the other thing I was doing right up until we were all ordered to just knock that off was I decided I made a resolution that I was going to go to mass every morning. I'm Catholic and practice regularly, but I don't typically go to morning mass every day. And I had started doing that. I'd been doing it for all of about a week and a couple of days when the quarantine took effect. So, okay. So you can see here in the query store plan table, right, and it lists out all of our different plans. We have a column that says, is this plan forced? What's the failure count of my forced plan? And what is the last failure reason, right? And here you can see, obviously, since we aren't having a reason, there is no reason that any of them are failing. So this is where this would show up for you if you were looking for a forced plan and then trying to find out whether or not it failed. And now I'm curious whether I put that, where did my tracked queries go? I want to put that in again. Plan ID number 6. I want to force it. And I want to go back and I want to rerun my query and see if it's actually getting forced. So I have a bad habit of trying to get ahead of myself. So let's take a look. So that would be plan ID 6, which is what we're looking at here. We should see the flag that says, is it a forced plan? That should be flagged. It is now, right there, number 1. But we aren't having a failure to force reason. And that's very interesting to me, because we actually should be having problems forcing that plan for the reasons that I outlined, and that I've got a new temporary object that's been invalidated by that plan. So not 100% sure why that's not happening. Maybe it's tempdb object reuse, maybe it's something else, but it's not working properly in this particular instance. And again, I apologize. I'm going to build a new demo. I'm going to smack my head against the monitor until it works, and then I'm going to send it out so that all of you guys can try it if you would like. Kevin, doesn't sound like I'm getting a lot of other questions.
So let's see. If you created the primary key with a true name instead of a dynamic name, you think that might possibly work?
So that's going to be better. If you create the primary key with a true name instead of a dynamically created name, you will not encounter plan failures due to the forced plan. It would not fix my issue where I'm trying to get it to fail to force the plan. It would actually make it less likely that a forced plan failure would occur.
That makes sense. Yeah, it looks like if there are any additional questions, now is a wonderful time to put them into chat.
Right. And so I do believe my email address was listed at the beginning of the presentation, but here it is again. I am somewhat active on Twitter. I do get notifications there. I'm not as active as I once was, but that's my handle there. You can also email me at one of those 2 emails, so that and I get both of them regularly. I monitor both of them. Although for my work email, I do tend to get a lot of alerts recently, to the tune of hundreds a day, and sometimes I do miss things. So if you don't hear back from me, don't assume it's because I'm a jerk. While I am a jerk, that's not why I don't respond to your emails. It's because probably I didn't see it. But if you send me an email and I don't respond, your second option is to send me an email and use the wrong form of the word your or their, really. And then I will immediately sense that, because I have a sixth sense about those things, and send you a correction and answer your question. And that
Now
is
you
all
all know the secret way to reach him.
There you go. All right, everybody, I really do thank you. And again, I apologize that my demo did not work as expected, and you'll hear back from me soon.
Excellent. Well, thank you very much for taking the time to talk to us about Query Store this evening. Even though you didn't talk about Column Store, that's still fine. So, Next week, we have Jess Schultz talking about Azure Data Engineering. We're going to have Shop Talk on Monday, and I may sneak in with another episode of Coding with Kevin in the meantime. So come on down for another session, another episode of another show, and hang out with us at the Triangle SQL Servers user group. So thanks again to Joseph for speaking tonight. Thank you all for hanging out in chat, and everybody have a great evening.
Thanks, everyone.